We're just going to go through the last two examples here where it says your choice of addition method, so I'll start with the easier, the triangle method, but if we have time, I will absolutely show you how to do parallelogram method. It's just a little more complicated. So we start with U, just like we did before, so we're going to say U is right here. We're going to go 1, 2, 3 to the right, 1, 2, 3 to the right, 1, 2, 3. There's U, and V will keep red. 1, 2, 3, 4, 1, 2, 3, 4. So the head to tail says 1, 2, 3, 4, 1, 2, 3, 4. So here is V down here. Now at this point, the only difference between the first couple examples and these is that rather than connecting the start of U to the end of V, I'm going to add a blue vector and just continue on, right? From the end of V, go to W. So up 2 over 1, and we have W. Okay. Now, if we had more vectors, we would just continue this pattern where you go head to tail. Since we're done, we have our 3 vectors. We treat it like the other ones, so we're going to start at the beginning of U and connect it to the end of W. So this vector is U plus V plus W. But that is our resulting vector. So I don't know, I've talked to kids in class and said, you know, maybe V is the vector of the boat in the water. We're trying to cut across, but there's a side wind, and that would be U, and then the current itself would be W. So it doesn't matter the order, honestly, either. I've had a lot of kids ask, you know, does it matter the order in which we create our vectors? And no, in fact, I'll just take a second right now. I'll demonstrate. So if we wanted to rearrange these, call this one W, call this one U, and this one V. So U is now this vector. So let's start here, right there. So if U is now this one, we'll go 1, 2, 3, 4, 1, 2, 3, 4. Okay, so we start with U. Now we call this one V is this one up 2 over 1. And we go head to tail, call that one V, go back to blue, and W is straight across 3, so we go 1, 2, 3. Coincidentally, we're going to create W is this. Now, what's interesting, and it just completely by chance, but what's happened here is my green vector, my resulting vector, is actually going to overlap. But again, we start at where we started our U, and we end at the end of W. So here's our resulting vector. Again, it doubles over or overlaps U. But if you look at it, look at our end result. We go down 2, left 2. I rearrange the order, and I still have a resulting vector that is down 2 and left 2. Okay, so again, that was just a quick demonstration that it does not matter the order of the vectors in vector addition. If we were to use the parallelogram method, let me save that to the end. So I will just fairly quick, I want to create the UVW using triangle method here. So let's see, I will start over here. U is over 2 up 1, over 2 up 1. Okay, that's U. V is left 3, so 1, 2, 3. So if we go, oh gosh, what am I doing? I'm sorry. Gotta change colors. Here we go. 1, 2, 3. So V, blue for W, and that is up 1, right 2, up 1, right 2. Okay, so that's W. And then if we go to green, we say here's our start of our vector, our resultant, and there's the end. So we kind of come up and along there. We got U, V, W. Okay. So vector addition using the triangle method. We have enough time here. So what I'm going to do is I'm going to go back and I will demonstrate how to do these using the parallelogram method. So we'll start same as we did before. Let me erase. Sorry, I'm going to clear up that. Okay. So now let's pick maybe like say right here. Okay. So U 1, 2, 3, 1, 2, 3. U looks like this. We're going to draw U like we did before. And we're even going to draw a V like we did before. So V using parallelogram methods is 1, 2, 3, 4, 1, 2, 3, 4. Parallelogram method says that we get to create 1, 2, 3, and the diagonal here. There we go. I really don't know what happened. Oh. When we create, see if I can create a kind of a new color. See, so our resulting vector here is gonna, let's go purple. Our resulting vector of U and V is gonna be this diagonal down this way, right? Because V is, or U is 1, 2, 3 over. So this is like U plus V itself. But at this point, we're gonna kind of ignore the U and the V separately. So what we have to do is we look at this as now purple is the combined vector U plus V. What we do is we take W and continue this parallelogram method up 2 over 1, up 2 over 1. Okay, here we go. And now, rather than trying to create some complex system, we just look at the purple, U plus V, and the W, and those two, the U plus V and W, create their own parallelogram. Okay. Purple. Like that. And again, as always, our resulting vector is green, and we get to draw it in. I'll draw it a little heavy so you can see that it overlapped our original. So here is our U plus V plus W. What you notice is no matter whether we looked at the original U plus V plus W, where it goes 1, 2 down and 1, 2 left, you look at parallelogram method down 2, left 2. So it's just a little more complex method, but you still get the same result. The idea is you take U and V and add them, and you basically create a new vector, U plus V. From the U plus V vector, you take W, and you use those two vectors to create your next parallelogram. So lastly, we will use that same method for this set of vectors. So we're going to start, as we always do, with our U vector, and we'll start right here. U vector is over 2 up 1. So we come across, we got U. And our V vector is, again, with parallelogram method, we start at the same place and go 2, 3. So there's V. Now at this point, our parallelogram looks like this and this. Fairly skinny, but we're going to make it work. We've got this resulting vector. Again, we're going to call this one u plus v, and we're calling it, coloring it purple, u plus v. At this point, u plus v is its own new vector. When you have three vectors you're trying to add using parallelogram method, at this point, we ignore u and v separately. We look at purple as kind of the first vector, and then again blue for w, and we're going to say, okay, so w is up 1 over 2, so up 1 over 2, and our vector is, well, our parallelogram is going to look really odd compared to some of these others, but if we just go back to drawing vector w, so here's w way down here. Our parallelogram is going to be, so we go up 1 over 1 for purple. So let me go to purple here. Purple says up 1 over 1, so we go up 1 over 1. So there, and our blue, other half the parallelogram is like that. So believe it or not, that is a parallelogram. And our resulting vector is that diagonal. So that's clear through the middle. It's kind of skinny, but we end at this point here. So that's u plus v plus w. But when you compare the two, our vector u, v, w for the first method is over 3 to the left and up 2. Believe it or not, over here, our resulting vector is over 3 to the left and up 2. So it did still work. It was just a little bit harder to see. But again, we want to practice that parallelogram method. Because as you will see here in the first official section, 4-1, that's kind of the method we'll use once we apply numbers to some of these vectors. But there you go. That is the introductory lesson to vector addition.